All right, part C of problem 1 is an example of a line integral of a function of three variables over a space curve C. Okay, now here the path C is the portion of this helix. R of t is equal to ti plus cosine 2tj plus sine 2tk, and we're taking for the portion of the helix t to vary from 0 to 2 pi. Okay, so this is this slinky curve that you can think of is wrapping around the cylinder of radius 2 that opens along the x-axis. Um, and so what we want to do is set up our line integral just as we did for part A and B, but notice here, since we're given the parameterization, we can kind of just jump straight into the integral. We're going to be integrating from 0 to 2 pi for the integrand. X is t, and then I have e to the, so what's y squared plus z squared? Let's do that just off to the side. So if I look at this portion right here, so y squared plus z squared, well, that's going to simplify, right? Because I just have cos squared 2t plus sine squared of 2t, and that's just equal to 1. So in fact, for this exponential part, I'm just going to get e to the negative 1 as we move along this portion of the helix, which is quite nice. And then ds, the differential arc length. Okay, so that's where we're going to want to compute the magnitude of the derivative of our vector function r, and then multiply by dt. So here I want to take the magnitude of the vector, and this would be just 1 for the I component. It'll be minus 2 sine 2t for the j component. So chain rule factor there is going to give you that 2 out in front. And then likewise here, we're going to get 2 cosine 2t for the k component of the derivative. And then we have our dt still. So now taking the magnitude, we're going to get 1 plus, and this is minus 2 sine 2t quantity squared plus 2 cosine 2t quantity squared. And we have our dt, and notice this right here, the 2 sine 2t quantity squared plus the 2 cosine 2t quantity squared. That's just going to give you 4 sine squared plus 4 cosine squared, and so that's just going to be 4. So 1 and 4 is 5. So taking the square root, we'll get root 5, and then we have our dt there. All right, so root 5 dt. And that is not a bad integral at all, okay, because we're really just integrating t. This e to the negative first and the root 5 are constant. I'll go ahead and pull those in front. So this root 5 over e, and then we have t squared over 2, and we're going to evaluate from 0 to 2 pi. So this is root 5 over e, and then that's going to give us a 4 pi squared, and then we're dividing by 2, plugging in 0 gives you 0, so that's going to give you 2 pi squared times this root 5 over e. Okay, so I'll write that as 2 root 5 pi squared all over e. All right, and that will do it. Thanks so much.